Let's begin this session with solving homework exercise number 15 from section 9.3. Selecting from milligram, gram, kilogram, and a metric ton, determine the best unit of measure to express a grasshopper's weight. Okay, a grasshopper is very, very, very light, correct? So the lightest unit we would probably want to use, which would be milligram, right? Again, gram is a paper clip, but a grasshopper is probably even much less lighter than a paper clip, so probably the appropriate measurement would be a milligram. Okay, so a milligram, possibly a grams, but I think a milligram would make better sense. All right. What measurement would be express the mass of a computer mouse? Again, a computer mouse is fairly light, but grams are only a weight of a paper clip. So the several paper clips would make up a computer mouse, so that would make sense. Millimeters is not even that's a length, so that doesn't make sense. And kilograms is, 1 kilogram is a couple of pounds, and a mouse doesn't weigh that much. So the most appropriate would be a gram. All right, homework exercise number 17. Express the mass of a football player. Okay, weight of a football player, again, kilometers is a length. That doesn't even make sense. Milligrams is a minute. If you're measuring something very, very small, like a grasshopper before, and kilograms, each kilogram is a couple of pounds, so definitely we would measure a football player in kilograms. Homework exercise number 18. The mass of a box of cereal, again, 600 kilograms would be hundreds of pounds, doesn't make sense. 600 grams, again, that would be about a half of a kilogram, which would be about a pound. So that would make sense. And again, 600 milligrams, milligrams is minute. So even though 600 is a big number, it would be less than 1 gram, because 1,000 milligrams make a gram, so that doesn't make sense. So 600 grams would be the only appropriate measurement for the mass of a box of cereal. All right, the mass of a box of carrots, again, carrots weigh a bit more. Again, milligrams is minute. It would weigh 0.75 grams. That doesn't make sense because 1 gram is a poker chip. So again, about 3/4 of a kilogram, so that would probably be about a little bit less than 2 pounds, and a box of carrots would probably weigh about that. So 0.75 kilograms is definitely appropriate. That could definitely be the mass of a box of carrots. The mass of a motorbike, again, the mass of a motorbike, or I'm sorry, let's do the mass of a refrigerator. Again, a refrigerator weighs several pounds, right? So again, decagrams is minute. It's just 10 grams. So again, that would just be equivalent to 900 grams, but that's not even 1 kilogram because 1,000 grams. And again, 90 grams is very small weight. That's not even a pound. So the only appropriate measure would have to be kilograms. 90 kilograms does indeed make sense. Okay, question number 21. We have, let's do a similar exercise. We have 6 items were purchased at a grocery store for 12 kilograms. One of the items is detergent weighing 750 grams. What's the total weight of the 5 others? So we got to take what? To find the weight, what's left would be the total 12 kilograms minus the weight of the detergent, right, to get what remains for the other 5 items. However, we want our answer in kilograms, but the weight of the detergent is in grams. So what we're going to do is we got to convert from grams to kilograms, and then we'll be able to subtract. You can't take grams from kilograms. So right here, the detergent, 755 grams. Remember, kilo, hecta, deca, and then grams is the unit by itself. So to go from grams to kilograms would be 1, 2, 3 jumps to the right. So 755, the decimals to the right of the number. So 1, 2, 3 would give us 0.755 kilograms. So the weight of the detergent is 0.755 kilograms. So the weight of the other 5 items, the total of the items 12 minus 0.755 for the weight of the detergent will give us the weight of the other 5 items. All right, so we can do that subtraction on our calculator to get the correct answer. Again, remember you have to change the weight of the detergent from grams to kilograms. 12 minus 0.755 grams gives us, and again, there's no approximation or rounding off, so put in all your decimals. So just put in my case, 11.245, the entire decimal, and it will mark it correct. Okay, if it costs, let's do a similar exercise here. I'll get a new problem. If it costs 48 cents to mail, 48 cents for mail weighing up to 1 ounce, so the first 1 ounce is 48 cents, 29 cents for each additional ounce or fraction. So even if it's a part of an ounce, you got to pay the entire 29 cents. Find the cost of mailing a letter that weighs 91 grams. Okay, so our 91 grams is our weight. Now, again, everything's based on ounces, so we got to convert grams to ounces, and it's not given in this problem, or if you hit similar exercise, you can get it, but the conversion is 1 ounce is equal to 28 grams, okay? If you think back to previous problems or go back to your textbook or find a chart, 1 ounce is 28 grams. So to convert here, we want ounces, right, in the numerator, because that's what we want. We want to convert to ounces, and we're going to divide by grams, which in this case, 1 ounce is 28 grams. So we use this conversion factor. Notice the 28 is in the denominator here, right? So we're going to go ahead and divide, okay? So we're going to do 91 divided by 28 to get the amount of grams. So 91 divided by 28, and we get 3.25 ounces. Now, remember what I mentioned previously, 29 cents for each additional ounce or fraction. So this 0.25, you really pay for the entire ounce. So what really you're going to pay, you're going to round up, right? And you got to pay for 4 ounces because this 0.25 is charged as if it was 1 more ounce. So it's equivalent to paying for 4 ounces. Now the first ounce is what? At its own rate of 48 cents. So we paid for 1 ounce, so 1 ounce take away, we're obviously from 4 ounces, we're left with 3 ounces to pay for, each 29 cents. So 29 times 3 is an additional 87 cents. So for the next 3 ounces to pay for 3 1/4, remember we had to round up to 4, is another 87 cents. So, and added with the first ounce at 48 cents gives us a total of 1.35, which of course stands for $1.35. Okay, so again, we converted from grams to ounces using our dimensional analysis, and then 3.25 ounces we had to pay for 4 because it's you have to pay for 29 cents for the entire, you have to pay 29 cents or equivalent to the entire ounce for any fraction. So we just ended up paying for 4 ounces. We did the problem with respect to 4 ounces. First ounce 48 cents, 3 ounces. The last 3 at 29 gives us 87 for a total of $1.35. All right, very good. We're going to stop this session here. If you have any questions, send me an email at tswierz@hodges.edu or call me at 239-938-7805. Thank you.